Section 2.3, Product and Quotient Rules, Higher Order Derivatives. Last time, in Section 2.2, we learned the basic differentiation rules. Today, we're going to learn how to take the derivative when we have a product of functions or a quotient of two functions. And not only that, we will take a look at how to take the derivative of higher orders, meaning second derivatives, third derivatives, fourth derivatives, and so on. Product rules. So when we have product of two functions, unfortunately, we don't get to just take the derivative of f times derivative of g. That's what we want to do, but then we will get the wrong answer. So here is a product rule, and you needed to remember it so that you don't take the derivative in a wrong way. So derivative of product of two function is you take the derivative of first function times second function plus first function times derivative of a second function. Do you understand? Yeah, so whenever you notice we are taking derivative of f times g, what you have to do is take the f prime times g plus f times g prime to get the right answer. You're going to have to remember that. And let's go ahead and do some practice problem. Let's just say we want to take the derivative of x squared times sine x. So what's really good is if you label on top of two functions, which one is a f, which one is g. And it is also helpful if you write f prime times g plus f times g prime. And what will be derivative of x squared? As you know, that will be 2x. And g, we don't take the derivative first time. You're just going to copy whatever g is. Plus, now this time, we're just going to write it down what the f is, which is x squared times, you're going to take the derivative of g only, and derivative of sine x is cosine x. And of course, I said it will be a good idea if we start practicing writing the answer as a factored form. So you look at these two terms and we see that common factor is an x. You can take it out the x, and you have then 2 sine x plus x cosine x. And that will be the answer of this problem. Do you understand? All right, find the derivative of h of x, where h of x is 5x plus 3x squared times quantity 1 minus 5x. You could multiply this out and make a polynomial and then take the derivative, then factor it. But because it's a product of two functions, it's okay to take the derivative using product rule. So again, you can call this one f and you can call this one g. So when you take the h prime of x, that will be equal to f prime times g plus f times g prime. So what would be f prime? Derivative of 5x is 5, and derivative of 3x squared is 6x, and then we're going to multiply by g the way it is, plus f is 5x plus 3x squared times derivative of g, derivative of 1 is 0, derivative of negative 5x is negative 5. Now we would like to simplify this. First expression, we're just going to have to FOIL. So let's multiply out. First and first, I get 5. Outer 2 minus 25x. Inner 2, I get positive 6x minus, last and last, 30x squared. And then this one, I only have a monomial times binomial. So you're just going to have to distribute that. And that will give you negative 25x minus 15x squared. So let's write our answer in descending order. So I have negative 30x squared minus 15x squared. That will give me negative 45x squared. And I have negative 25x minus 25x, which is negative 50x plus 6x will give me negative 44x. And then last constant you have is just positive 5, so that will be positive 5. And negative 45x squared minus 44x plus 5 does not factor, so you can leave your answer as negative 45x squared minus 44x plus 5. Let's do one more. Y equals square root of x times quantity 3 plus 2x. So to take the derivative of this, it will be better if we rewrite square root of x as a rational exponent function. So let's go ahead and rewrite this as x to the 1/2 power times quantity 3 plus 2x. And again, it will be good idea to label above each function f and g, so that when you take the derivative y prime, you will need f prime times g plus f times g prime. So what is the f prime? When you take the derivative of x to the 1/2 power, power comes down, 1/2 comes to the front, x to the, you lose 1 power from 1/2, 1/2 subtract 1 is negative 1/2 times g, we don't change anything, we just write g, plus f. This time, we don't do anything to f, but only taking derivative of g, which is derivative of 3 is 0, derivative of 2x is 2. Now we want to simplify this. We don't want any fraction inside of our parentheses, so let's take this 1/2 out, and then between x to the negative 1/2 power and x to the positive 1/2 power, we always choose lower exponent, right? So that will be x to the negative 1/2 power out. Then from the fourth term, you can see this is out, so all you have left is quantity 3 plus 2x. So quantity 3 plus 2x will go inside of a bracket with the plus, and because you took half out, you're going to have to multiply 2 with the number inside there. So that will be number 4. So that half times 4 gives you 2 back. And because you took x to the negative 1/2 out, it's going to be x to the what power? Negative 1/2 power plus what half gives you positive 1/2. That will be 2 over 2 power, which is 1. So that will be just x to the 4th power, which is just x. Very nice, right? So then you will only have a bracket on the numerator. So let's simplify. When you add the 2x and 4x, you get 6x plus 3, 1/2, and 2 is denominator. So let's put the 2 in the bottom, and x to the negative 1/2 power needs to go to the denominator because it is negative exponent. So let's send it to the bottom, and it becomes positive 1/2 power. And you can see on the numerator, I have a common factor 3, so you can take it out, and you get 2x plus 1 over x to the 1/2 power was radical x. So here is your simplified answer. Quotient rule. So if you have a quotient of two functions and you want to take the derivative, as you see the formula right here, it is a lot more complicated than the product rule. So to take the derivative of f of x over g of x, you need to do g of x times f prime of x minus this time f of x times g prime of x over, you gotta square the g of x. And because it's a minus in the middle, you cannot switch their order. And as you see, a minus b is not equal to b minus a. Subtraction is not commutative. So order really matters, unlike product rule. So some genius guy came up with this, which makes our quotient rule a lot easier to memorize. So everybody, let's sing this. Low D high minus high D low over square below. Pretty cool, huh? One more time. Low D high minus high D low over square below. And literally, you do what it says. Of quotient of two functions, there is a function who sits on the numerator, we call it high, and function who sits in the denominator, let's call it low. And what you do is you do low, which one's low? G, D high, derivative of high, minus high, high is F, D low, derivative of low, over square below. Perfect, right? And that's exactly what you do. This really help out. I love this. You will love it too. So that way quotient rule is no longer hard for anybody. So guys, let's go ahead and do this. But after all this practice, some people just take the derivative of top over derivative of low in the test. And that will be wrong, right? So make sure you don't do that. You use quotient rule, otherwise we get the wrong answer. Let's take the derivative of this. Evaluate derivative of quantity x squared plus 3 over quantity x cubed minus 4. Okay, so we're gonna call the top expression high, bottom expression low, and let's use quotient rule. So we have low x cubed minus 4, d high, derivative of high will be 2x minus high is x squared plus 3, d low, that will be derivative of low, which is 3x squared, over square below will be x cubed minus 4 squared. We got it. So now we just need to simplify this. So on the numerator, do you see any common factor to take it out? I see both have a common factor x. So I'm gonna take the x out. So when you take x out, I still have a 2 there, so I'm gonna distribute the 2 here and write inside of a bracket. So that will be 2x cubed minus 8. And when you take the one of the x out, I still have a 3x left there, but there's also minus. So minus will distribute to both of them, which make both the terms negative, but you gotta also distribute the 3x with it. So what you're gonna get will be minus 3x to the third power, since you did the minus x squared times 3x. So that's a minus 3x cubed, and that minus distributed to 3, and then 3x distributed from the right. So that will give you negative 9x over x cubed minus 4 squared equals, and if I clean up the numerator, x inside of a bracket, if you clean it up, I get negative x cubed. I got that from 2x cubed minus 3x cubed minus 9x minus 8 over x cubed minus 4 squared. And because every term inside of my bracket is minus, I'm gonna pull that out. Then I'm gonna have a negative x cubed plus 9x plus 8 over x cubed minus 4 square. And x cubed plus 9x plus 8 doesn't factor anymore, so you can leave your answer like this. Let's do a couple more examples how to take the derivative of quotients of two functions. Find the derivative of y equal quantity 1 minus cosine x over sine x. So my high function is 1 minus cosine x. My low function is sine x. You ready? Y prime then is equal to low sine x times d high, derivative of 1 is 0, and I have a minus, derivative of cosine x is negative sine x. So double negative made it positive. So low d high minus high. My high is 1 minus cosine x. You just write the high. D low. I need to write derivative of low, and derivative of sine x is cosine x over square below. And my below is a sine x, so I need to square that. So I get sine square x, which is equal to sine x times the sine x is sine square x. I'm going to distribute this negative to here and here, but I'm also going to distribute the cosine x to here and there. So then you are gonna get minus 1 times cosine x is minus cosine x, minus minus cosine x times cosine x gives you plus cosine square x over sine square x. Can I simplify anything here? I see sine square x plus cosine square x. What is sine square x plus cosine square x always equal to, everybody? Yes, that will be 1. So you're gonna get 1 minus cosine x over sine square x. Wait a minute. Sine square x plus cosine square x equal 1. We just said sine square x plus cosine square x equal 1. Then what is sine square x always equal to? 1 minus cosine square x, yeah? So I can change my denominator to 1 minus cosine square x. Why would you want to do that? Because then 1 minus cosine square x is 1 square minus cosine square x. So it will be factored as a minus b times a plus b. So it will factor 1 minus cosine x times 1 plus cosine x. So then I will have a common factor to cancel. So my final answer then 1 over 1 plus cosine x. So now that we have a quotient rule, we can actually derive the derivative of a tangent function. We have a derivative of sine x, which is a cosine x. We have a derivative of cosine x, which was negative sine x. But we don't have a derivative of tangent x formula yet, and you are about to have one now. So what is the derivative of tangent x? Well, guys, what's the tangent x? Tangent x, as you know, is correct. It's a sine x over cosine x. So you can rewrite this as derivative of sine x over cosine x. Then now we can use a quotient rule, right? So that will be equal to low is cosine x times d high. What's the derivative of sine x? Cosine x minus high. So high is sine x times d low. Derivative of cosine x is negative sine x over square below. So I gotta square the cosine x, which I get cosine square x. Then my numerator become cosine square x. Negative sine x times negative sine x gives me positive sine square x over cosine square x. Again, cosine square x plus sine square x is 1 over cosine square x. But guys, what is 1 over cosine x? That's right, that's a secant x. And this is 1 over cosine x times 1 over cosine x. So it is secant square x. Yay! So you have now formula for derivative of tangent x. But I could always ask you to derive a derivative of tangent x, and this is how you would do it. Now you can fill out all this formula. Derivative of sine x, as you know, is cosine x. Derivative of cosine x is negative sine x. Derivative of tangent x, we just did it, secant square x. I want you to find out what the other three is, but actually do the proof of it. So rewrite the cotangent x as what? Cosine x over sine x, and do the quotient rule. And what is the secant x? Secant x is 1 over cosine x. So rewrite as a 1 over cosine x, and you can do the quotient rule. And what's the cosecant x? That will be 1 over sine x. So write that and then do the quotient rule and fill out these three. That will be your homework to do. And then you want to memorize it. But from this point on, we will use it like a formula. So I will give you the answer, but you do the rest of a proof for the other three, all right? So the answer, derivative of cotangent x is negative cosecant square x. And derivative of secant x is secant x times tangent x. And then derivative of cosecant x is negative cosecant x times cotangent x. Isn't that so funny? The sine and tangent and secant, derivative of them is all positive. All the trig functions that start with the letter C, their derivatives are all negative. That's kind of easier to remember, huh? That will help you to memorize the sign together. So let's go ahead and evaluate derivative of 5x squared times cotangent x. We're going to do this assuming that we already have memorized this all formula for all the derivative of 6 trigonometric functions. Evaluate derivative of 5x squared times cotangent x. So let's call this f times g. Then I gotta use product rule, right? So that will be f prime times g plus f times g prime is what I have to do. That's the product rule. So derivative of 5x squared is 10x times g. G is just cotangent x plus f. I just copy f, which is 5x squared times g prime. Now I gotta take the derivative of cotangent x. You have it right here, right? Derivative of cotangent x is negative cosecant square x. So now, can we clean up anything? We do have a common factor, correct? I got 10x and 5x squared. They both have a common factor, 5x. So let's take the 5x out. So your answer is gonna be then 5x times 2 cotangent x minus, you still have an x because you only took the 5x out from the 5x squared, cosecant square x. I think that's good enough. You can leave your answer like this. You better memorize that derivative of secant x equals secant x tangent x. Find the equation of the line tangent to fx equal secant x at the point 5 pi over 3 comma 2. Can we find the equation of a tangent line? We have done it before. Let's do it. To find the equation of a tangent line, we need slope and a point. Point, they gave it to you. I just need the slope. And to find the slope at this point, I need to find the derivative, slope function. So to find the slope m at x equal 5 pi over 3, you just need to find the f prime of 5 pi over 3. So what is f prime of x? Because f of x is a secant x, and you have a formula. F prime of x equal secant x tangent x. So f prime of 5 pi over 3 will be equal to secant of 5 pi over 3 times tangent of 5 pi over 3, which is equal to find the secant 5 pi over 3, I'd rather calculate 1 over cosine of 5 pi over 3 times 5 pi over 3 is in quadrant 4, right? So all students take calculus. So in quadrant 4, only cosine is positive. So tangent's gonna be negative. And since it's angle in quadrant 4, reference angle will be 2 pi minus the theta. Your theta is 5 pi over 3, which is 6 pi over 3 minus 5 pi over 3. So your reference angle is pi over 3. So tangent pi over 3 is, it's a radical 3, but we do have a minus already for quadrant 4. And same thing, cosine is positive there, so we know it's gonna be positive. And cosine of pi over 3 is 1/2. And since you did 1 over 1/2, it will be 2. And 2 times negative radical 3 will give you negative 2 radical 3. So that's the slope. So you found the slope and you have an ordered pair point. So now to find the equation of a line, you can use a point slope form of a line. And because it didn't say what kind of equation they want, you can actually leave the point slope form of a line. And point slope form of a line was y minus y1 equal m parenthesis x minus x1. So I just plug it in. Y minus 2 equal, my slope is negative 2 radical 3 parenthesis x minus 5 pi over 3. And I found my equation of a line tangent to f of x equals secant x at the point 5 pi over 3 comma 2. Now, let's take a look at higher order derivatives. This is not hard at all. We have to keep taking the first derivative, which is f prime of x. And you know f prime of x can be written differently. We use dfx respect to x, or because f of x is equal to y, we could also write dy dx notation, and that's also called the y prime. If you take the derivative of f prime of x, now you get get second derivative. And you can use f double prime of x, and that will be derivative of f prime of x respect to x, because f prime of x is df of x respect to x. If you just substitute as f prime of x, that's what you get. And if you just look at notation wise, it's a d square on the top then over dx square. So second derivative, we could also use this notation, d square of f of x dx square. And that's the same as d dx of y prime, which is d dy dx respect to x. Then another way of writing it will be d square y over dx square. It's also called y double prime. Got it? Likewise, third derivative, f triple prime of x, or we could use d cube of f of x dx cube, or y triple prime. From fourth derivative, we do not use prime anymore. You use f, and on your right upper corner of f, you would have to put little parentheses and you put a number there. For example, if you want fourth derivative of f, that will be f fourth derivative of x. Don't write f of power 4 of x. That will be f times f times f times f, not the derivative. So make sure you put parentheses so that everybody know you meant the fourth derivative, not the power 4. And the fifth, sixth, seventh, eighth, you would use the same notation. So this is for any nth derivative of f. So let's do an example. Let's say I have f of x equal 3 sine x. What will be first derivative? Well, derivative of 3 sine x, 3 stays the same, and derivative of sine x is cosine x. And then what will be second derivative? 3 stays the same, and derivative of cosine x is negative sine x, which is equal to negative 3 sine x, then is what's the f double prime of x is. What would it be f triple prime of x? That will be, you would leave the negative 3 the same, and derivative of sine x, which is cosine of x. So that will be negative 3 cosine x. And what will be the fourth derivative of this function? That will be, you leave the negative 3 the same, and derivative of cosine x will be negative sine x. Negative 3 times negative sine x is positive 3 sine x. You notice that fourth derivative of f of x is back to same as f of x. So now fifth derivative of f of x will be equal to the f prime of x. So anyway, fifth derivative of x will be 3 times derivative of sine x is cosine x. So it will be 3 cosine x. So you notice for this function, I could go like this forever. Let's do the next one though. Next one is polynomial. And you know, for a polynomial, every time I take the derivative, I lose 1 power. Alright, so what is the fourth derivative? You had a 4, and then bring down the power 3, you lose 1 power, plus 2 times, you bring down power 2 and lose 1 power, that will be x to the fourth power now, plus derivative of 7x is just 7. Derivative of a constant is 0. So when you simplify, it is 12x squared plus 4x plus 7. And now let's take the derivative of that, which will give us a second derivative. So second derivative now is 12 times, putting the power 2 down, lose 1 power, so you get x, plus derivative of 4x is just 4. Derivative of a constant is 0. So I'm just gonna get 24x plus 4. Third derivative will be derivative of second derivative. So you take the derivative of second derivative, then I'm just gonna get 24 this time. And if you take the derivative of a constant, I get 0. So fourth derivative is 0. And fifth derivative of f will be also 0. So actually, from here, all the derivative is 0. Recall, we learned this from 2.2, the particle motion. Given position function s of t, we can have a velocity function v sub t, which is equal to s prime of t. So first derivative of a position function will give us velocity function. And now we learned that acceleration function is the derivative of a velocity function. So now you know that is actually the second derivative of a position function. General position function from 2.2. We learned that s of t was equal to 1/2 gt squared plus v naught t plus s naught. And if we are in US, we use the g for negative 32 feet per second square. So 1/2 times negative 32 will give you negative 16. So you could just memorize this instead, which is negative 16 t squared plus v naught t plus s naught. But of course, this will not be what we will be using in the metric system though. Anyway, let's do a problem. A particle is shot upward with an initial velocity of 32 feet per second. So they gave you initial velocity, which is v sub naught, which is equal to 32 feet per second. That's what v sub naught is, from a height of 48 feet. So since this is where initial height of an object was, this will be s of naught, 48 feet. Give the equation which models its position. So our s of t will be equal to negative 16t squared plus v naught t, 32t, plus s naught, so that will be plus 48. Find the maximum height the object reaches. So actually you will learn this more in chapter 3. But when you look at the s of t, this is parabola upside down, right? You know, you will have actually maximum, and maximum will happen right here. And you can see there your slope is 0. So given this is the position function, the slope function, which is the velocity function, and velocity function has to be 0 in order for this position function to reach the maximum height. So knowing that, let's go ahead and find the s prime of t. S prime of t is the velocity function, and that will be equal to negative 32t plus 32. So set that equal to 0 for the maximum height, and I will get negative 32t equal negative 32. Divide both sides by negative 32. I get t equal 1 second. So I know I will have a maximum height when t is equal 1 second, but it's asking to find the maximum height. So after you found when, you can plug this back into the position function to find the maximum height, since position function is the one that gives you maximum height. So s of 1, which is equal to negative 16 times 1 squared plus 32 times 1 plus 48, which is negative 16 plus 32 plus 48, which is 16 plus 48, which is 64 feet. So your maximum height is 64 feet. Find the velocity of the object when it hits the ground. We saw something like this before, right? When it hits the ground, when object hits the ground, s of t, position is 0, right? This is the hint, and they're saying that, hey, position is 0. So set the position equals 0 to find out when that's happening, meaning find the time t. And then you can plug it into velocity function. And you already found the velocity function, and velocity function is right here. Your velocity function is negative 32t plus 32. So let's first find out when it hits the ground. I have negative 16t squared plus 32t plus 48 equals 0. I can see that these are all multiples of 16. So I'm going to divide both sides by negative 16 to make my coefficient simpler. So if I do that, then I get t squared minus 2t minus 3 equals 0. Wow, this will be easy factoring. This factors t minus 3, t plus 1 equals 0. So t must be 3, or t could be negative 1, but t cannot be negative 1. T is the time, right? So in 3 seconds, it hits the ground, And we are going to plug this to the velocity function because it says find the velocity of the object when it hits the ground. Well, it hits the ground at 3 seconds, and velocity at 3 seconds will be v sub 3. And v sub 3 is, remember, this is your velocity function right here, so you plug 3 right here. Negative 32 times 3 plus 32, which is equal to negative 96 plus 32, which is equal to negative 64 feet per second for the velocity. And I have been asked before from student, how do you get negative 64? It's because when ball hits the ground, ball was coming down, not coming up. So velocity for moving object, when you're going up, velocity will be positive. If it comes down, it will be negative. On the axis, if a particle is moving to the right, velocity will be positive. If a particle is moving to the left, velocity will be negative. Okay guys, this is all for 2.3.